So this evening we have two very talented speakers ahead. We've got Lovee Jain, our senior software engineer at Prezzee, and then also Kishan Mananda, who is also over there, our senior software engineer from Simply Wall Street. So yeah, thank you again, everyone, for coming, and I will hand over to Lovee. Can you hear me? Oh, yes, it's on. Okay. It's better now. I'll actually have been sharing my screen, so I'll stop sharing and reshare. Okay, I think we're on. So hello, everyone. Thank you for coming. I am Lovee Jain, and I am a senior software engineer here at Prezzee, a Women Techmakers Ambassador, and also a GDG Melbourne Organiser. And tonight, I'll be talking about serverlessing like a pro. So what do we have on the agenda is, we're going to talk about what is serverless, and then straight away get into creating a serverless function. We'll explore what's beyond functions, a couple of use cases, and then I have got a little Memo demo, and then we'll conclude with some best practices. So before I do that, I'd like to gauge the audience here. So how many of you here have deployed or managed service before? Wow, that's a lot. How many of you here are starting with cloud and have heard of serverless? Cool. So serverless, does it mean no servers? Not really. There would still be some servers, but you won't be the one managing them. It will be done by your cloud provider. So over the period of time, there has been a shift observed from focusing more on your business logic and less on deploying, less on managing the underlying infrastructures. So earlier, when you used to have physical servers, then you would be having to manage them, configure them, the operating system, the networking, patching, and whatnot. And they would always keep running, even if you're not using them, and you would be paying for an idle time. And then came virtual machines. Now, virtual machines obviously help in better resource utilization, but you would still be managing the service like the operating system, networking, patching, et cetera, et cetera. And then containers were introduced. So how many of you here know or heard about Docker? Yeah, cool. That's good. Anyway, so Docker popularized this concept of packaging your deployment and application code with dependencies as a container so that you can run it on any infrastructure. However, when it came to scaling, it was challenging. And the containers, they always keep running. So you're still paying for the idle time. Solution, serverless. Serverless basically abstract away all the underlying infrastructure so that you can actually focus only on your business logic. So if your business logic is all about adding two numbers, that's what you focus on, adding two numbers. That's it. How it is going to run or what machine, what operating system, you really don't care about it. What you do care about is where you're going to deploy it. You might want to deploy it closer to your customers. So that's your responsibility. So what are serverless functions? Serverless functions are basically single-purpose modules of code. They can be triggered or invoked instantly. So through events. An example of an event could be, say, you made an HTTP request, or maybe you're triggering it or running it every day at 2 p.m. That's a timer trigger. Or you uploaded an image on a bucket. and that's what is triggering it. So that is a trigger. So a trigger or is basically something that invokes this serverless function. And once it has done its processing, say it's going to update a database or something like that, it just done the processing and it vanishes away. With function, you can also have a logging. It helps you understand the behavior, debugging, and optimizing it. Some of the pros and cons of the functions would be, so pros, pay-per-use. Now, as I mentioned, your function runs when you trigger it, and once it's done processing, it vanishes away. That means you're only paying for the resources you use. So it's pretty cheap sometimes. Serverless functions, they can automatically scale based on demand, ensuring smooth performance under spikes. Next, faster time to market. Now that you have time to focus only on your business logic, you actually bring your code or your functions or your services really quickly to the market. Polyglot, it offers, you can write functions in so many different languages: Java, Go, JavaScript, Python, whatever you want. And because now the infrastructure is not your responsibility, it's cloud provider's responsibility, they make sure that your functions are highly available and there is more fault tolerance. And obviously, better resource utilization. Talking about some of the cons though. So as I mentioned, your function needs to be triggered. So there is a bit of a cold start observed. That means there's a bit of a latency observed. And in my experience, I have observed about 200 milliseconds of latency. So you might want to be careful when you are using serverless functions for your customer-facing apps. Next, statelessness. So when you call functions multiple times, each of those invocations, they don't really know about each other. So there's not a very good way of maintaining a state. We are going to discuss more about stateless or statefulness, actually, in the upcoming slides. And because next is limited customization. Now, you're not managing the infrastructure. So obviously, you have limited options, but there are actually plenty of limited options. So they're not really, really limited. So, okay, moving on. Let's actually straight away create a function. So before we do that, I have to mention this, that you can use either the cloud provider's console to create a function. You can use the text editor extensions to create functions. It's very, very helpful and helps you do things very quickly. And you can do it locally, which we are going to do now. And if you need more hand-holding, then there are tools like Copilot or Gemini. So use them. Okay, so we are going to create and debug an HTTP triggered Lambda function that is going to add 2 numbers. And we are going to deploy from our local CLI. Now, if you get lost in the way, I have got an article that can get you started with serverless functions, GCP, AWS, Azure, anything you like. I'll be sharing the links later on. Okay, so I'll need to stop sharing. Okay. Okay. All right. Can you? Is this zoomed in enough? I think so. Can you see it zoomed in enough? Right? Okay. So for getting started to deploy functions from your CLI, you need to actually have that cloud provider CLI. So we are doing AWS Lambda. That means we need AWS CLI. So I've already got it installed. And the tool that I'm going to use is Serverless Application Model, which is SAM. And SAM is really popular to get you started with serverless applications. So I have configured that one as well. So once you have done those steps, it's really very easy to do, to create a function. So let's do this. So I'm going to do a SAM init. And that's going to give me the whole step-by-step instructions, and we can do things. So template source, AWS Quick Start templates, yes, please. Hello world example, yep. And runtime, popular runtime package, Python and zip, yep. Extra tracing, no. Monitoring with CloudWatch, yes. Structured logging, yes. Project name, SAMApp, yep. And ta-da, it's already done. You have it, you've already created it. Okay, so let me just open it in my VS Code. I know there's this shortcut, but it doesn't work on mine, sorry. Okay, I'm going to use the most boring way of opening things. Somewhere it must have created it. Created it the wrong place, but that's fine. Okay, there we go. So let me zoom that in. Oh. Okay, this is enough. So this is just standard Python stuff. As you can see, there we go, there's the app, and this is what you are actually interested in. So that's your function code, and all it does is, when you run it, it's gonna give you a message, hello world. Pretty easy, isn't it? Then the other file that you might be interested in is event.json. Now, event.json basically is like an event that you actually give to your Lambda. So when you are making that request. So we are going to use it, and we have this one, and the next one, the important thing is the template that you might be interested in. Now, this template is your infrastructure as code, and it contains all the resources that will be deployed when you are deploying this function. So it has got the hello world function, and this could be, if you see the events, it has the type API, and the path is hello, and the method is get. Easy. So let's start the terminal and actually invoke this. Ooh. Gets really weird when you zoom it in so much. Okay. And it's invoking it. And by the way, when you're doing AWS functions locally, you need Docker. So don't forget to install it and things. So there you go. You can see it has got the message as hello world. Easy. Now, when I did say that we're going to add 2 numbers. So I don't see that here. So let's actually change the code and add 2 numbers. So I have got it in my notes, and I am simply going to copy this without using too much brain. And there you go. So what I'm going to do is I'm going to pass 2 numbers, A and B, and it's just going to give me the sum of it. Okay. And if I go to my template, I will actually update the function method from get to post. Now, I don't like to call my function statically. It doesn't give me that dev experience. I like when I can make changes and it hot reloads. I can see it. I can call it from my Postman. It gives me a good URL to call. So for that, I'm going to run a different command, which is, hang on, I forget. Yes, that's correct. Okay. So there you go. It has already started. It's on localhost 3000. And it's a post call, you can see. So I'm going to just open my Postman. I have got the payload ready, everything. I'm just going to put in the URL and maybe change the numbers and then call it. There you go. It's able to add 2 numbers. Yes, you've done it. The next step is, oh, actually, we need to see hot reloading. So let's actually go back to app.py and change this to and see the results again. Ta-da, hot reloading. So that's what gives me the proper experience, right? So that's it. I'm happy with my function. So the next thing I'm going to do is deploy guided. So I'm just going to run it as it is, deploy guided, but I'm going to pass it another parameter called profile so that I deploy it on my personal account and not on my work account. Okay, so now it's going to create a whole set of resources, which is like a change set, right? So it's like a stack that you're deploying. So it needs a name. So stack name, SAMAP, sure. AP Southeast, okay. Confirm, yep. Role creation, yes, you always need it. Disable rollback, no. Now it has no authentication, is this okay? Sure. Let's go while, okay. Save arguments to a configuration file, yes, you do that so that you don't have to run this whole lots of steps. And the name is going to be SAM configure terminal, okay. And then default, and that's it. It's gonna create a change set for me. And then it's going to ask me, tell me what all the resources it's going to add. So if you look at, okay, if you look at this one, you have got all these resources that it is going to deploy. And you'd say yes. And while it is doing that, let's actually check out our AWS console. Come on, move. Okay. All right. Is this zoomed in too much? That's why. This is better. Okay. So this is my AWS console, and in the cloud formation is where you actually see your change sets. And this is the stack that we are deploying. A stack, having it all grouped together is very helpful. You can delete the resources on the go. You can actually do a lot of things like update the resources in the same stack when you're making changes. So while it is doing that, let's actually quickly also explore what all are the events that are happening. So, woo, it already created it really quick. And these are the resources it has created, and it has got some outputs. I am interested in this output because this is my function endpoint. And now in my Postman, I am going to replace it with this one. And actually, let's change the numbers. Woohoo, done. We've already deployed it. It's already on cloud. You're running your function. It's a serverless function. Let's actually have a look how it looks like. So on the resources section, if you go to Hello World function, that's where you're going to see your Lambda. Now this is your Lambda, and this is the trigger. And this trigger triggers this Lambda. This is all the function code that I did not write the commented code, but this is the code I wrote. If I want, I can do some tests. If I want, I can look at the monitoring. If I go to CloudWatch logs, I can, because I called this function, I can actually see the invocation, that had happened. So this is from today, right? And then there's configurations, permissions, and triggers, and all the other things that you might need when you're doing functions. So, all righty. Let's actually get back to the presentation. I'll actually reshare. Okay. Okay, wait, sorry. Yeah, better. All right, so I have been talking about serverless and functions together interchangeably, but it is actually a lot more than that. It is more of a paradigm shift in how we build and deploy applications, where we abstract away the underlying infrastructure complexity. You can deploy an entire stack of services that respond to specific events or requests. They can scale to zero when no longer in use. And for provisioning and management, it's all done by the cloud provider. All the behind the scene details are actually invisible to developers. So what do we have beyond functions? We have serverless database and storage. So unlike the old ways of the database and storage, which was limited, serverless databases and storage, with them you have automatic scaling, built-in replication, and global distribution. You have serverless containers. Now, at the start of the talk, we did touch upon containers. They provide a lightweight and portable way to package your application code and its dependency, ensuring consistency across different environments. But when it came to managing these containers at scales, it was a bit of a challenge, and it requires expertise in orchestration, scaling, and a lot of resource management. But with serverless container platform, it abstracts away all the complexities of managing clusters and instances so that you can scale them automatically based on demand, and you only pay for the resources that you use. If you are looking for serverless container platform, what are they on Azure? They are Azure Container Instances. For AWS, it's Fargate. For Google or GCP, it's Google Cloud Run. Next up, serverless data processing. Now, there's a difference between data storage and data processing. What we are talking about here is ETL, or extract, transform, load workloads, or data analysis, real-time processing, batch processing, simulations, AI data model processing. These kind of jobs, they consume a lot of CPU and memory and execution time. With serverless, it abstracts away all the complexities of distributed data processing. So if you have an ETL job that has to transform or convert a JSON into an XML, that's only you focus on. How it's going to be done, not your problem. So what you would be looking for is Azure Data Factory, Amazon Kinesis, or Cloud Data Flow. Finally, my favorite, serverless workflows. Now, serverless workflows can automate complex business processes by chaining together various tasks and services, all without managing service. They're very useful in building integrations. With Visual Editor or declarative YAML syntax, it even offers a low-code, no-code approach. What you'd be looking for is in Azure Logic Apps, Google Cloud Workflows, or AWS Step Functions. Now, I just talked about chaining. So let's actually discuss more about it. Let's consider an example where you have a customer, they add a product to their cart, and what you want to do is, as soon as they do that, you want to send them an email and say, hooray, you've added a product to the cart. So what will happen is that adding a product to the cart is going to be your trigger. And that's what is going to invoke your function. Now, what your function might do is grab the details of the product, details of the user, convert and put them into an email template, and then finally send it to your customer, right? But if your function does all of this, it might actually time out. So solution would be that you do it in multiple functions and you chain them together. So now what is going to happen is, all right, so the customer puts the product in the cart, it triggers the first function. And that function basically grabs the details of the product of the customer and triggers the second function with the details. And the second function develops the template, and then it triggers the third function, just like what's happening there. It's very distracting, I know, but that's actually what is chaining, really, right? But with this, if you have noticed, I'll move on to the next slide so that you can focus here. Okay, but with this, what you have achieved is a move from statelessness to statefulness, because you have already passed in a context from one function to another. And so earlier, when I said that functions, they are stateless, that means each of the invocations, they don't really know about each other. But with this, you can actually pass in the context. It's quite helpful to maintain context or session information between invocations. So for example, you have user authentication tokens, session IDs, or intermediate processing results. So the other example is you can actually have fan-in, fan-out thing. So what you do is you trigger multiple lambdas, and then you wait for them to finish, and then you finally aggregate and then call another function. You can even have async APIs or long-running applications. So for example, if your function is basically calling another application, which is going to really take a long time, and your function may time out. So instead of timing out, you can actually redirect your users to a status endpoint that the client polls to learn when the operation is finished. And alternatively, if you do not like any of these options, you can always leverage the in-memory caching solutions, such as AWS Elastic Cache, Google Cloud Memory Store, or Azure Cache for Redis. to temporarily cache stateful data within the serverless functions execution environment. And I think, Oliver, you mentioned to me that we also have AWS instance for Redis. Yes. Yes. So yeah, even that. Okay. By the way, you can also implement webhooks in serverless. Now, talking about webhooks, let's come to the final piece of the puzzle, event-driven architecture. So in an event-driven architecture, the flow of data and control in the application is driven by events. So earlier in our example, when the customer placed the product into their cart, it was triggering a function. Now this time, it is going to publish an event on an event bus or a topic. Now that event bus or topic is actually subscribed by the function, the template function, or actually grabbing the detail function. Now that function is already subscribing to it. It sees a message has come up and it's like, oh, let me consume it. It's going to consume it. And then it's going to grab the product details, the user details, everything. And then it's going to publish another event to another event bus. And from there, there are two subscribers. One could be your data processor, which means it wants to know, maybe you want to process some data, store some data or do something with it, like what products are being added by customers. Or it could be subscribed by the template generator function. And then you can actually chain that template function with the email sender function. So you can actually mix and match. Isn't that cool? So basically, communication is done by publishing and consuming events. With event-driven design, you can create loosely coupled architecture. It's quite resilient as well as scalable. Okay, now let's have a very quick look at multiple use cases. Microservices. While microservices can also be built and operated using PaaS or containers, serverless has gained a significant momentum given its attributes around small bits of code, inherent and automatic scaling, rapid provisioning, a pricing model that never charges for an idle capacity. API backends. You can actually create fully featured APIs plugged in with an API gateway that brings additional security, OAuth support, rate limiting, and custom domain support. BFFs. Now, this is my favorite topic. I have given a full talk on this, so definitely check it out. I have got the link afterwards. So BFFs are basically your backends for frontends. They're neither your backends, they're not your frontends. They are like a thin layer that act as a custom backend for your frontend to fulfill that frontend's custom needs. So you can actually create those. Next up, data processing, ETL, as I mentioned, structured, unstructured data, image processing, OCR, et cetera, et cetera. Stream processing, real-time data processing pipelines, IoT sensor data, financial market data. You can use serverless for everything. And integrations. I love this one because I have developed super useful integrations before. We used to have actually a legacy application. So it was really hard to communicate with it. With that integration or the logic apps, it made it so much convenient to move data from here and there. So for an instance, there used to be a file on an FTP server, and we used to pick up that file, add details to a database. We used to transform that file, and then we would used to put it back on an FTP at a different location. So all we did was just use these low-code, no-code approaches, actually, to get this done. So all serverless, logic apps and function apps in Azure. Low-code, no-code. So obviously, it empowers users to develop their own minor integrations, helping automate day-to-day tasks. And generative AI. How can I forget this? I added this morning because I know if someone will ask me about it, because it's gaining so much of popularity. So serverless with generative AI is like the next big thing. I think it's already here. So it allows you building and deploying AI applications without worrying about any server maintenance. So I think Google's Vertex AI and Amazon's Bedrock, they provide serverless experience that allows you to get started like really quickly. Okay, so I think we have some time for a Memo demo. So are you ready to see some developer memes? Okay, all we are going to do is look at some memes. No, not really. What we are going to do is we are going to look at some memes, but then we are going to upload them on a cloud storage. Now, this is a GCP demo, right? We are going to upload it on a cloud storage, which is going to trigger a cloud function. And then the cloud function is going to grab the details of the image and put it on a image queue, which is subscribed by my Cloud Run application. Now it grabs those details, basically the image, and then it uses Cloud Vision API to read the text in that image. And if the text has some certain keywords, such as Microsoft, Azure, AWS, Amazon, Google, or GCP, it's going to pass those texts on the cloud name queue. As soon as a cloud, the name gets onto the cloud name queue, it is subscribed by Cloud Workflow. It's going to pick that name, and it's going to update that cloud sheet over there. So let's actually get started with looking at the cloud sheet. So I'll stop sharing and reshare. Okay. So that's my cloud sheet. The count is 0. And what we are going to do is, let me open some memes. So the meme one of the day is this. How many of you have burnt all your cash because of this? All right. The point is, it has the keyword AWS, and I am going to upload this image on my, so this is my cloud console, the GCP console, and this is my storage bucket, and this is where I'm going to upload it. So as soon as it is going to upload it, it's going to trigger my image queue function. Now, let me just refresh these logs. I have been trying, so it already has it. But we're going to see some fresh logs. So it looks like these are some fresh logs, although the time is IST. I don't like it. Anyway, it has got that. And then what it is going to do is it's going to publish it on a topic. So I have got multiple topics. So I think the first one was image queue. Yep. So you can actually check messages and things. And then it's going to push it onto my Cloud Run application. So if you look at the Cloud Run application, and if you look at the logs, it has got it, and it doesn't seem right. Oh, it is. Okay. That's AWS. And then I have got this huge workflow, which is going to update my cloud sheet. There you go. We have an updated count. Okay, meme number 2. So now this has 2 keywords. Let's upload this one and check. Okay, it's gonna run it again. And actually wait for it. So Microsoft and Azure. Woo, it has updated the count. Okay, next up. Who's done this? Well, it has GCP. So let's upload this one. And let's see if it updates the count for GCP. Come on, do it. Oh, yay, done. So cool, isn't it? So now I have got more memes, but in the interest of time, I'm gonna skip and go back to our presentation. Okay. All right, so that was a little meme demo right there, and we are going to conclude with some best practices. So focus on small single-purpose functions. So you don't want your function to do everything. It will time out, it won't work. So have smaller functions, and then leverage the event-driven architecture. It's going to make your life a lot easier. You might think it's a lot of things that you're deploying, but at the end of the day, you can scale things or apps individually. It makes it a lot decoupled. And then implement efficient monitoring and logging. Always the case. Utilize caching mechanisms. It's actually quite helpful when you have caching involved, because the latency that you see at the start of a function, if you have cached already, then you won't see that, right? You straight away give it from the cache. And design for security. So I don't know if you noticed, when we did our live coding thing, we allowed the unauthenticated access to our application. Don't do that. That's not the good way to do it. But yeah, design for security. So I think that's it. Oh, wow, it's stuck at this slide. Come on, I want to thank. Oh, this is funny. Okay, wait. I have to share the QR. I'll share it again. Oh, what am I doing? Press that. Oh, thank you. Any questions? Any questions? Wow, you're a nice audience. Oh, yes.
Oh, sorry.
Thanks for the talk. It was amazing. I just wanted to know your view on step functions. Like, how would you compare your regular lambdas with AWS step functions?
Yeah, to be honest, the execution is quite different. Yes.
Thanks.
But if you talk about the workflows, that's the closest you have. Yeah. Yes.
My question is, how do you maintain?
Sorry, just for the people online.
Hello, everybody online. So my question is, when you have like 1 or 2 functions, or maybe even 10, 15, I think it's manageable. But when it comes to like a proper full application where there are like heaps and heaps of functions you have to manage, how do you manage all that function? Because they're all in a different functions, you know, in the cloud. So how do you manage that in scale?
Why would you have different functions? You can actually create an instance and run it together, right? You can run it on Fargate. You can just run it on a container.
No, I mean, that is good, but Lambda, I'm talking about Lambda.
So yeah, so you have multiple lambdas. How do you manage?
The code, yep.
Well, it totally depends on yourself. You can create a monorepo. Like we are actually in the process of doing something similar.
Yeah.
So we are creating a monorepo kind of a thing for like our team, where we are going to put all the functions, such kind of functions together.
Okay.
Yeah.
Thank you.
Yeah, you can even have, so it depends. Like, for example, if they are relatable functions, you can actually put it in the same template and refer to the same API gateway. But if you have very different usages, you can create separate, totally separate things.
Cool, thanks.
Any more questions? Cool. That's cool. Thank you.
Thank you, Lovee.
Thank you so much.